Before we dive into our first keynote address, I want to make sure you know about the addition of our point of view narrative documentary series, as well as our extraordinary performances to all of our online conferences. We are very excited to bring both our POV and extraordinary performance together at the end of our live day programming this year in our grand finale event. Join us as we dive into how recent developments in AI have helped to create a more agile working environment in sports in Beyond Moneyball, AI in Sports. Then stay tuned as we round out our day with an incredible performance by principal bassist with the New York Philharmonic, Timothy Cobb, accompanied by the renowned classical concert pianist Jeannie Schneider. You truly don't want to miss this spectacular event. Now, let's get started. Our first keynote speaker is Joe Justice, who will explain how nearly flat management works in companies like Tesla in his keynote on Your Boss's Data, How Digital Self-Management, DSM, works. Joe will look at topics ranging from KPI selection, machine learning for management, promotion and demotion criteria, and data collection. We look forward to seeing you at the live Q&A immediately following this session.
I'm Joe Justice, former Tesla employee. A lot of people write about what it's like to work for Elon Musk, what it's like to work in Tesla, what it's like to work in Neuralink, what it's like to work in SpaceX, but most of them haven't ever been in the company. They've only read about it or thought about it. I'm really happy to share my experiences consulting to a Musk company and then becoming an employee in Tesla. The shocking point that I want to talk to everybody about today is how there's essentially no management. Elon always says, the best part is no part. The best manager is no manager. What we would say in the Musk companies every day is, you have no boss. Your boss is data. I call this digital self-management. Using software, mostly machine learning software or AI, to replace management decisions. You can try a basic version of this yourself today. You can go to ChatGPT from OpenAI or Bard from Google. Those are two fairly advanced systems. And you can ask anything you might ask a manager. And when you're managing, you can ask anything that people ask you. And ChatGPT, for example, will first say, I don't know your context. I don't know the history or background of the request about this decision. I don't know details of the people involved. But in general, sound management advice is these things. And the answers are very good. They're as good or better than the answers I've encountered from any manager in any previous company, ever. The software in the Musk companies does know the context. It knows what projects people are working on, what projects they used to work on, how much money those projects are spending, how quickly the KPIs those projects are intended to improve are improving. It knows how volatile the projects are in terms of people coming and going, in terms of budget change or steady budget, in terms of KPI growth or KPI degradation. And with that information, the software running in the Musk companies can make excellent management decisions. This is called hashtag digital self-management, or DSM. The idea of DSM is any approval that waits for a manager is automated by software. This software has largely replaced management. This software is called digital self-management and allows nearly 100% of staff to be an engineer, directly improving the products every day. This improves financial efficiency. I created a car company in 2006 called Team WIKISPEED. We set 4 world records. We worked collaboratively with 4,000 people all around the world. We ultimately won the 24 Hours of Nürburgring race in Germany, which for car people, it's one of the most famous car races on one of the most famous car racetracks in the world. We won the 6-cylinder class in 2014. I worked with the International Institute for Learning, sharing how I learned management in that company, globally distributed management in real time.
Welcome to WIKISPEED.
That let me then work in the Musk companies to consult and establish and create the Agile program there. What I saw in terms of management there was completely next level. I've never seen any company with digital self-management anywhere near like the Musk companies use. And I'm not aware of any software package made by any company that's headed towards what the Musk companies already have. What I would recommend for every company is put a large budget on building your own DSM software. Because once you have even some recurring management decisions automated by software, and it's at least not worse than humans, it's now instant. You've knocked delay out of your company. Pace of innovation is the only thing that matters. And pace of innovation cannot go faster than approvals. The more of your approvals become essentially instant through DSM, the faster your company's throughput of innovation, the fundamental winning formula. Unfortunately, there's not yet a software package that you can just buy that's quality. This currently you'd need to do what the Musk companies do, where you build your own. Replacing human decision points with apps is the digital backbone of a modern company and fundamentally determines the speed of product development and response. Hashtag digital self-management means saying, why would we ever ask a human to decide this? And being honest. There's YouTube videos of many of the pieces I'll show as we cycle through. Some are hosted on my own channel, Joe Justice Zero. Some are hosted by Tesla, SpaceX, or Neuralink. The DSM in the Musk companies is fed by real data, sensors, physical sensors. For example, there are farms running hardware tests at SpaceX, Tesla, and Neuralink, and these farms never stop. 24 hours a day, 7 days a week, these sensors are running materials tests, fatigue tests, accelerated aging tests to create part libraries of material sciences data. When you draw a new part in a Musk company, it's assisted. The software is suggesting and auto-completing 3D drawings and engineering data with you. The data that feeds that machine learning, the assisted engineering, comes from physical measurement that Tesla takes itself, that the Musk companies take themselves. And it comes from measurement farms like this. Any iteration review in hardware means hardware is fully tested, homologated, certified, and in production. This means every single car and rocket puts itself through automated testing of every non-destructive compliance and certification test. This is called factory mode, and it is where autopilot came from. We can't sell something new faster than we can certify it as approved for sale. Most car companies certify something approved for sale every 5 years, some things every 2.5 years, and very few things every 3 months. The Musk companies certify several times a day. This is what the screens in the car look like when it's running. Factory mode tests each piece of the car as it's assembled and then tests as they talk together. Each airbag, each camera, each compute system. Here is a very recent view of factory mode running as this Model Y is being assembled. Modules are tested individually in factory mode and then tested again as soon as they are connected to the car. Here is the steering column, part you steer. It's testing its connection to the steering rack, the part that steers the wheels. It's connecting to the infotainment system, the heat pump, the cameras, the full self-driving computer. They're testing themselves because they are all potentially unique. This Model Y may be different than the one in front of it and different than the one behind it flowing through the factory. They all test each other. When you make 10,000 cars, 1 million cars the same way, You only have to test a sample set. If pace of innovation is the only thing that matters, you need to test every car so you can introduce change at any point. And this is exactly what Tesla does through factory mode. Factory mode is a self-learning collection of apps, and it replaces management saying, should we introduce this change to production now? Instead, you introduce the change to production immediately and see if metrics go up or down. You don't ask for an approval. Imagine that if you're an engineer working on a part for one of these cars, you're working on the manufacturing line in the same building at the point of manufacturing. At the moment, the software packages say your prototype part is better than the parts being installed on the car already. You install that one part in the car and it's sold. That means each day there's a mix of different types of cars being sold. It looks like this. You have automated testing, definition of ready testing of any manufacturing point in the factory. Design and manufacturing are not separated. Any manufacturing point includes developing new versions of that part. That's responsible because of automated testing for legal compliance and quality and ease of use and maintenance at the end of every assembly point, which we call definition of done. Next to you, there's a team developing additional types of new parts. And they don't just develop them, they also build them. In prototype, maybe they can make 1, 2, 10, or 100 parts in a day. So there's a mix of the parts you're making and the parts the people next to you are making, branching together, both being sold in different batches. In this drawing, I've put only 2. There's actually 10 or more side by side and on top of each other. So you have a mix of 10 or more versions of almost every single part at all times. This is an agile line, and it creates the fastest pace of new product introduction possible. Here is the heating and cooling system of Tesla's sedan and SUV, the Model S and Model X. They're large sedan, large SUV. It has these parts, or had these parts, these cooling systems, these heating systems. It was replaced by a fewer part system developed for the Model 3. What's important for the business is Tesla didn't wait 3 to 7 years to introduce this simpler system. They introduced it the minute it was passing tests. So there was a period of time where some Model S sedans had what we call resistive heating, a less efficient form of heating, and some had these heat pumps, far more efficient, and they were being made at the same time. That system is made simpler and simpler every day until now it's this stack of systems. These are made like a toy car, and they're much less expensive. They're much more efficient. They last longer. They're easier to maintain. And this didn't wait for any approval. As soon as the digital systems, the digital self-management said this system is higher quality than the previous system, the engineers working on this immediately started installing these parts in production. Even if they've only made a few parts by hand, those are installed, and those engineers are now part of what's called the production ramp. How do we make many of these parts? The fundamental reason this goes so fast is because management and approval points is software. It's not perfect, but it's nearly instant. 100 plus subcomponents were eliminated. Here's exactly what it looks like. On the production line, in the production floor, they 3D print, they form plastic, they stamp metal, they machine metal. Some parts do come from suppliers, but typically same day turnaround, small volume suppliers. And they install and sell these heat pumps. As they're building, teams are working with them, adding automation, creating automation of these manual assembly steps of this new version of the heat pump. As they're working, These teams and teams with them are also simulating not only the design, so they can have assisted design, machine learning helping propose better design decisions, but also simulating the manufacturing process, which is also assisted. Machine learning is proposing better manufacturing processes, but also it's letting the humans better understand the possibilities of manufacturing and better automate them. This results in cost dropping and time dropping. In most car companies, you might see a cost reduction every 3 years when a set of new parts is approved. Remember, the Musk companies don't have to wait on approvals. Those are instant from software. So you'd expect to see price drop a little bit constantly and recognize earlier cost reduction, a lower cost of delay, which is a fundamental Agile best principle. And in fact, that's exactly what we see here. You can see a combination of daily pennies reduced, yen reduced, rupees reduced, euro reduced every day. Weight goes down in grams and in kilograms, grams every day, and it combines for kilograms. Power draw comes down from all the systems. This happens to be the central infotainment system being measured here. But all of the systems, power draw continually collapses, decreases. So the system continues to draw less power, which means more range and higher performance available for the car. The system continues to reduce in weight, again, higher performance, more range. And cost drops, better business model, and a lower price to the consumer. That results in a 30% cost reduction on the Tesla Model 3, the small sedan, over a 4-year time span. For any other car company, they would wait for a major model change every 5 to 7 years, and they would hope for a 1% cost increase only. For most companies, cost of production only increases. In Tesla's case, the cost of production drops 30% in less than the time it would take for a company to change their profit model at all, which typically only gets worse. That means quicker charge times. The consumer-facing experience gets better a little bit every day. Less seconds to charge every day or every week, which compounds over years to be dramatically reduced charge times. Inside the factory, the fundamental business model of the factory, output goes up, whereas labor hours go down. The automation of production and design ramps every day. Machine learning, AI, is proposing better production methods, better production processes, better production machinery, better allocation of talent, better allocation of labor, and people are also doing that. The data set of running the factory is fed in real time into these machine learning algorithms. And it works. This isn't only once a quarter that a change, a kaizen, a kaikaku happens in the factory. These are seconds every day. Output grows up by a few cars every day. Labor hours go down by a few seconds every hour. This is true all around the world because this management structure is shared in Germany, in the Netherlands, in the United States, in California, in Texas, in New York, in Shanghai, China, etc. What's important is to automate acceptance tests of digital self-management for definition of ready, for newly designed and existing parts coming in, and definition of done, newly designed or existing parts going out. This automation is largely inspected visually, also inspected with X-ray, also inspected sonically. But in all cases, a visualization is generated, which makes a video feed, and the video feed is processed by Tesla Vision. It looks like this. Powerful in-house software allows the engineers and the software to visualize what's happening electronically, heat-wise, electromagnetically inside the entire parts of Tesla products. This feeds automation of design, and automation of production. I'm often asked, can this work in highly regulated industries like pharmaceuticals, like vaccines? I'm working with vaccine companies right now, companies that make COVID-19 vaccines and others, and they're seeing approval speeds from the world's governments faster than they ever had before. Here's part of how that looks. Neuralink is hardware. It's medical hardware, an implant inside your head, and it has a sequence of very thin wires going into dense neural areas in the brain to listen to what the brain is doing in that area and also to stimulate, to communicate to that brain in that area. Effectively, you can image a screen and like virtually type. That's a very baby version of what Neuralink should eventually do. It should allow you to think and perceive in much more detail. But in the beginning, we can think about it like seeing a screen inside your mind, like imagining a screen and virtually typing on it. Again, the final end game is much more interesting, but already you have a very fast, essentially unspeed limited rate of typing and ever present optimal definition screen in your mind. What's interesting here is seeing Neuralink employees admit that they start with a large suite of automated acceptance tests in manufacturing. It starts with manufacturing. This medical device, this amazing front-running, groundbreaking medical device, starts with automatically measuring how manufacturing is working. The engineers who design also work on the physical manufacturing. This is what's called benchtop. These are mobs, groups of employees in Neuralink. They're designing new Neuralink computers, which are about the size of a smartwatch. So you can think of it like designing and building a smartwatch. And these same engineers also build it. So they're assembling these here on benchtops. They're making small components. They're downloading software into components. They're using magnetic resonance to measure what's going on inside these components once they're sealed. And they're creating full stack talent. People who are able to design, build, and manufacture the device. And they switch teams across this development environment. In this case, it's called benchtop. We then collect data from these implants around the clock, and this data is processed and feeds back into our design process and empowers our engineers. The goal is to put these devices in brains, and right now pigs and monkeys, as fast as practical, and that real data is displayed on the benchtop as these engineers are designing and building the next product. They started with about 6 months from design to in a brain. Now these iterations are as short as 45 minutes, legally approved. And this is some of the highest hurdle, highest certification authority to clear. If embeddable medical devices can be iterated legally in 45 minutes or less, you can, whatever your industry, your banking model, your B2B model, your B2C model, your software sales shop, your insurance model, it can also do it. What you need is to start automating some of your decision-making in the company and eventually automate your bottlenecks one at a time and fundamentally improve the speed of certification inside your company, and then automatically package up your certification request packages for government. Then do what Tesla does. Send a small certification application every day. Get it smaller and smaller, 1 page if you can. Try to certify a small modification to an existing product. The agency builds trust, understands how you work with them, and you start to get a faster pace of approval. In Neuralink's case, the actual probes that go into the brain, The goal is for them to be so small so they can navigate carefully, safely, healthily to the parts of the brain where they have the most high utility, the most benefit. They need to be strong enough that they can reach that point without deforming, but then no bigger than absolutely required. So there's no known perfect design. Always striving for these probes to become slightly smaller, slightly thinner, have better placement accuracy. And these probes are now changing physically every 45 minutes. Machine learning is continually running to improve the engineering. Humans are continually assisting the machine learning to improve the designs, and they're making them, physically making them. More and more of the manufacturing process and inspection process is automated, which continues to shave off seconds. It's a game of seconds, and it compounds over time. The future is to iterate even faster. They iterate on what Neuralink calls the benchtop, which means not yet in a brain. They have mock brains made out of different layers of gel and plastics that behave like the different layers of many different types of brain. And they move them. The brain is actually moving at all times. So these different layers move like layers of clouds and ocean shifting around each other as these probes navigate to attempt to be placed in the highest value area. There's also simulation model, and those simulations become more smarter by watching real-time MRIs of the actual brains where these devices are implanted and running MRIs on these prosthetics, these plastic, rubber, and gel brains, and how the physical movements run improves the simulations. And the simulations improve the physical model. Interestingly, looking back at Tesla data, it's still absolutely about humans. This digital self-management is about maximizing human happiness, capability, creativity. The more engaged, passionately engaged the humans are, the safer these facilities are and the safer their products. This is measured by digital self-management. And digital self-management shows us that the more engaged the employees are, the fewer work-related injuries, the safer the products, and also the more employees want to work for Musk companies. The Musk companies are currently the #1 chosen companies to work in by graduating engineers in the United States and most of Europe, and on average worldwide. In fact, the #1 and #2 choices are SpaceX and Tesla, and which it is which year alternates. This isn't because the engineers have the highest salaries. In fact, the engineers in the Musk companies have very low salaries. The median income in Tesla is around $52,000 US a year. The average person you encounter working these companies is making $52,000 US a year. These are some of the top machine learning minds in the world, some of the top manufacturing engineers in the world, some of the top production athletes in the world, and the median income is much lower than you might think in another company. What inspired me and seemed to inspire most of the people I was working with when I was a Tesla employee was how quickly you feel success. When you have these machine learning aids, guides, and digital managers, you get to go so fast. Any other company feels like it's in slow motion, and it's frustrating to work in any other company. It feels free, it feels happy, it feels light. Would you like to know more about Tesla's in-house software? Again, this software is made in-house. I have never seen any vended software package getting anywhere near this. There's a news article from a few years ago that lists some Tesla software packages. They got a few parts a little wrong, but it gives you a unique data point from someone other than me. Here's a screen capture of my actual mobile phone from when I worked in Tesla. These are some of the actual apps that were installed when I became an employee. Here's an excerpt from the news article, so you're not hearing from only me. Among Tesla's many homemade business applications is a purchasing order system called Warp, previously known as Warp Drive. Warp is also used for car work orders in service centers. Besides Warp, Tesla has created several other programs, including TMOS, its manufacturing operating system, to track where a Model 3 is in process of manufacturing, repairs, and testing. This is not entirely accurate. TMOS is used for everything, all cars, all products. It's a very broadly used set of applications working together. MES, a manufacturing execution system to support production of its Model S and X vehicles. Again, MES runs on all products. A Tesla executive factory dashboard to show equipment effectiveness and line data and high-level production numbers to executives. This is not for executives, it's for everyone. It's on everyone's phone, it's on every screen. You can't stand anywhere in a Tesla facility and not see at least one of these screens. Huge, big and visible. This is the most visible front end of digital self-management, showing you all the key KPIs of the business model of the company. This allows you as any employee to work in a team with other employees that you form that team, and improve these KPIs in real time, which is exactly how the company essentially self-manages. Garage or Garage Portal to let workers locate a Tesla vehicle and see which firmware updates customers may have gotten or may need. Garage shows a lot more than just firmware, but yes, it shows you the digital twin of all Tesla cars. There's more than 3 million Tesla cars on the road now. In Garage, you can see all of them. And this system now finally has an all-inclusive name, Tesla One. Elon's vision is to build a vertically integrated organization where information flow happens seamlessly across departments and where we have closed feedback loop to our customers. By doing this, we can provide the best possible product, service, and overall experience to our customers in the fastest way possible, while also operating efficiently as a business to bring this vision to life. We had to have a simple and central business operations software that could connect all departments and enable information flow seamlessly across departments. Again, we couldn't find one software program in the market that satisfied this need. Tesla One trademark registration is intended to cover the categories of downloadable computer software in the nature of mobile application for document management, workforce timekeeping and scheduling, analysis of employee time and activity, tracking purchase orders and returns, completing customizable comment forms, and database management. This is a grouping of all of these ML apps and other traditional apps running together in the Tesla ecosystem. The goal is for 100% of staff to be engineers in hardware and software. Any work that requires taking someone away from engineering is automated as much as practical. The result is a high financial efficiency of the company. In fact, it's impossible to compete with this business model with a traditional business model. If 20, 40, even 60% in some cases of your workforce is not directly improving the product or service, you cannot compete for the same amount of money against a company with similar headcount where near 100% of headcount is directly improving the product or service. The method to achieve that is digital self-management. You can think of it like email. If a company has paper mail and years ago never used email, it'd be hard to explain to that company the advantage of paperless office communication, of email. And now you could not find a company without email or even faster than email real-time chat. That's what's happening to management. Management is paper mail. Human management is paper mail. Assisted management is email. Full AI management is real-time chat in Teams. That analogy is simply going to become more and more true over the next months and the next year, few years. My recommendation, start a digital self-management project now. If you're in position to allocate budget, allocate as much budget as you can. I would actually recommend 50% of total company budget. which is approximately what the Musk companies are doing to continuously reinforce their DSM. Run that project as a lean startup with clear KPIs. Use the best agile practices you can and improve your decision-making bottlenecks one at a time. Don't wait for the software to be perfect. Wait for its success to be similar to a human. And as long as it's faster, start using it immediately. One key approval at a time, automate them. It's a game like Lean, where you save a second and another second and another second, and you win. I'm Joe Justice. You can reach me on Twitter at Joe Justice. You can reach me on YouTube, Joe Justice 0. And it's my pleasure to be collaborating with you today as part of the Agile Business Institute and with the International Institute for Learning.